Okay, so we got some function z equals f of xy, and I want to talk about partial derivatives. So I'm going to use this little thing here. Yeah, xy plane is here, and this top of this thing is mimics the surface of f of xy. Okay. So this is like just a slice out of the f of xy graph. We slice it here, we slice it here, we slice it here, we slice it here, and we've got this little segment. We've got a normal plane up here, although I've cut this thing to have a little bit of curvature, right? But we can approximate the top of this thing by a normal plane, which we can easily find, or at least we're going to be able to easily find it if we've got the function. Okay? So let's just say that this point right here, now this is the xy plane down here, this point is some point xy, right? Then the slice that I make in this direction, if I could slice it without actually hitting the, okay? Slice that I make in this direction, this face here is kind of a trapezoid of the graph of f of xy confined to this plane, okay? So I'm, and in this plane, x is constant, right? So now I've taken the graph of the function in two variables and confined my attention to just one, to what happens for one value of x. And there's some function that, follows that value of x, and I'll kind of try to draw this on the board too. But the point is now that this is the part of the curve that you get when you slice the f of xy function, the graph of the f of xy function. And this has a slope. Well, whatever the slope is the approximate partial derivative of this function with respect to y for that value of x and y, the value of x and y you have here. And if you just did the tangent right there, the tangent to this curve at this point, that would be, the slope of that tangent line would be the partial derivative. And that's something you want to think about until you really understand it. Now, I can kind of sketch that, okay, and wish me luck. Okay, here we've got our x, y, z, and I confine myself to some value of x, say x naught. So here it is, right? And we've already seen level surfaces, so if I evaluate, if I do z equals f of whatever this x is, then I'm replacing this x with some value, and now I have just a function of y. And that function of y will have some curve. So here I am in the plane x equals x0, okay? So this is f of xy confined to the plane x equals x naught, okay? Now, if I also just pick a value of y here and call it y naught, so that now this point is, see how I want to label it, this point is a point x naught, y naught, okay? Now I can look at this function in the vicinity of the point x naught, y naught, okay? And now I've got a little curve here, okay? And the derivative, partial derivative of f of xy with respect to y, because y is varying here, is just the slope of the tangent line at this point. And that's a partial derivative of f with respect to y. I don't write a D, I write this kind of, I'm not even sure what the name of this thing is. Okay, it's not a Greek delta, but it's a partial derivative symbol, okay? Just kind of a smooth curve, kind of like almost like a rho as opposed to a P, okay? But maybe a little slightly different shape and of course inverted. Okay, this is a partial derivative of f with respect to y at the point x naught, y naught. Okay? Now we're going to give a definition of this in a minute, but I can kind of draw a bigger picture of this. Okay, so here's the tangent at this point, confined to the point x equals plane x equals x naught. Okay? Now we know that we have a tangent plane at this point as well. We're familiar with that idea. And this little segment is just the intersection of a small part of that tangent plane with the x equals x naught slice. Okay? The plane x equals x naught. And of course, the slope between this point and this point is an approximation. Okay? So, I'll label this as the tangent is the slope. And I say tangent slope, there's not really such a thing as a tangent slope. But, and here is the approximate slope. Okay? Okay, well, what I'm going to say now, this point here is the point x naught, y naught, okay? If this distance here is delta x, then what are the coordinates of this point?
X plus delta x.
And I'm sorry, that shouldn't be delta x because x isn't changing in the plane x equals x naught. That should be delta y, I'm sorry.
Yeah. So it's x naught, y naught plus delta y.
Okay, so this is point x naught, y naught plus delta y. Right? So what is the length of this little segment here?
Z, or f of x naught, y naught.
Yeah, f of x naught, y naught. It is a z. Okay, but we're going to have more than one z, so we can call it z naught if we wanted to, but there's really no reason. I'm not going to even use it. And this is f of x naught, y naught plus delta y. Okay? Okay, well, what's the expression for the approximate slope?